So here's try it number 5. What is the equation of J? Write the equation in vertex form and in the form f of x is equal to ax squared plus bx plus c. So starting problem A, we're going to say that J of x is equal to, this is our vertex form. And two things we want to look at here are that it's going 2 units right and 5 units down. So remember, this is going to determine my h, left, right is h, and up, down is my k value. So J of x would be equal to a times x. H is going to be 2 units right, so it's the opposite of what we would think. That means we're going to subtract 2. And then k is going 5 units down, so that's straightforward. We're just going to subtract 5. Now for these problems, as I mentioned in the previous video, normally you would have to figure out what a is. You'd have to calculate that by using a graph. But since there's no stretch, there's no compression, and there's no reflection, a is just going to be equal to 1. So we're going to say that J of x is equal to, if you want to write a 1 in, you can. I'm just going to leave it as is. So that's my vertex form. And now we need to convert this to f of x is equal to ax squared plus bx plus c. So to do that, we're going to write the x minus 2 squared as x minus 2 times x minus 2. You'll then distribute those. So we're going to get x squared minus 2x plus 4 minus 5. Combine your like terms, and then we get x squared minus 4x minus 1. So J of x will be equal to x squared minus 4x minus 1. Let's take a look at problem B. So same thing, we want to start with vertex form. This time it says let J be a quadratic function whose graph is a reflection of the graph of f in the x-axis followed by a translation. So it's going to go 1 unit down. It's important for us. But here, what's very important is there's a reflection of the graph of f in the x-axis. So we want to keep that in mind. We'll get to that in a second. There is no shift left and right here. So my J of x, I have a times x minus h. My h, because there's no shift left and right, I'm going to write the 0 in. It's going to be gone in a second, but right now just as a placeholder. And then since it shifts down, we're going to write 1 unit down. So that k value is that minus 1 there. Now, since there is a reflection of the graph of f in the x-axis, that reflects or affects a. So what's going to happen is that a is going to be negative because there's a reflection. Since there's no stretch or compression, it's going to stay as a negative 1. And I know that might sound a little tricky, but since there's a reflection, remember reflections mean that a is negative. We'll clean this up because we don't need h in there anymore. So we're going to say negative 1 times x squared. And then we can leave that as is. That's our vertex form. If you want to, again, leave that 0 in there. It's not the worst thing in the world, but you do want to clean it up a bit. Now from here, they're asking you for ax squared plus bx plus c. So J of x would be equal to x squared is just x squared, right? X times x, and then minus 1. So J of x would be equal to, well, I'm just going to rewrite the same thing because there's no like terms. In this case, my b value is 0, so that kind of disappears. And then that is my answer. J of x would be equal to negative 1x squared minus 1. The key thing, though, in part B is that the reflection is going to cause a to be negative, so you'll have a negative 1. And once again, it's a 1 because there is no stretch and no compression. For these problems, if there was a stretch or compression, you would need a graph because you would have to find out a second point, and then you would need that second point to calculate what A is. But for these, you won't have to worry about that. There will be no stretches and no compressions in these specific types of problems.